Welcome to NASA's Jet Propulsion Laboratory in Southern California. Today we are celebrating the one-year anniversary of the Perseverance rover safely landing on the surface of Mars. Now we are in an area of the lab called the Mars Yard, which is a simulated Martian environment where tests are done. And we have a couple special guests joining us today. We have Swati Mohan and Rachel Kroniak, who are part of the Perseverance mission. Now, Swati, you might remember her as the commentator who announced that the rover safely touched down on the surface of Mars while being in mission control, and Rachel is currently working on the science operations side of things. Now, they will be answering any questions you might have. If you would like to ask a question, use the Ask NASA hashtag or leave your comments in the chat box. Now, to get started, I have a couple questions for you. Swati, can you believe it's been a year?
I can't. It's gone by so fast. I can't believe it's been a year already since landing day.
And around this time last year, you were in mission control. What was that like?
You know, leading up to the landing, that week before, we were all super stressed and worried, making sure everything was going right. There's so many different pieces to landing that have to go perfectly in order to reach the ground safely. You know, we had our share of heart-stopping moments during the entry, descent, and landing, but to be able to confirm that we were on the surface safely, to get that first image back from Mars, was just an incredible relief and an amazing feeling for the whole team.
And you were on the engineering side of things. Now, Rachel, as part of the science operations team, what are you and the mission up to now?
Yeah, so like Raquel mentioned, I'm on the science operations team, so I get to help build the plans of activities that we send up to the rover every single day. And a year ago, we landed in a place called Jezero Crater, which is home to an ancient river delta, which we think is a really good place to look for signs of ancient life on Mars. Now, we ended up landing a couple of kilometers to the east of the delta, and so for the past year, we've been spending our time exploring the rocks that make up the crater floor. And once we wrap up our crater floor activities, we're going to be making a beeline to the delta, which is going to be the next location for our next science campaign.
And as you can hear, it's kind of busy here in the Mars Yard today. Can you explain why this area is important for rover operations?
Yeah, so the Mars Yard is a really special place for us to test and practice all sorts of things with our Earth-based version of Perseverance named Optimism before we do them for real on Mars. And if there's anything that we know for certain about Mars, is that Mars is oftentimes unpredictable. And so the Mars Yard is a really special asset for us to be able to troubleshoot when we encounter unexpected things on Mars.
And what is your favorite memory of the Perseverance mission so far?
Gosh, it's so hard to pick just one because it's been a really exciting year. A memory that sticks out for me was a couple of months after landing when we were getting ready to send up our first activity plan, telling Perseverance to collect our first rock sample. So this was something that we were working on for weeks and months leading up to that day. So when the day was finally here, it was super exciting. It was also very nerve-wracking, and like Swati said about landing, it was a huge relief once we were able to do it.
Sure. What about you, Swati?
I echo Rachel in that it's really hard to pick just one, but I would have to say it's pretty hard to beat landing day. It was the culmination of all of the work that we had done for so many years, you know, the hard nights and the long nights and the testing and the good things and the bad things kind of coming together with all the memories associated with it for that successful day that kind of encapsulates the whole mission for me.
And after that, what did you do next?
So Rachel mentioned the first sample acquisition on Mars. That's really important actually, because Perseverance was the first leg of Mars sample return. So the fact that we confirmed that we got one sample successfully kind of kicked off a multi-agency effort to bring those samples back to Earth. I'm working on one part of that campaign, which is a lander that will go to Mars with a rocket on it that is intended to get the samples off the surface of Mars into space.
Now, after you wrapped up the mission, is that typical for an employee of JPL to start on a new mission?
It is actually. When we wrap up one mission, we often go to the next one that needs the help. So the Mars 2020 Perseverance team actually went to multiple different missions. They went to Psyche, which is next up in launch this year. to Europa Clipper, which is next on about a few years from now, and then also to the Sample Retrieval Lander, which has a little bit longer runway until it launches.
Uh, as you can tell, it's really, really noisy here today, but we're going to see some familiar faces, as Swati mentioned, and we're going to get to some viewer questions now. So if you have a question you'd like to ask, please use the Ask NASA hashtag or leave your comments in the chat box. So first up, Provinx on Instagram asks, how long did it take to complete the rover's construction? Swati, do you want to take that one?
Sure. So Mars 2020 as a project started very soon after Curiosity landed, around 2011, 2012. That's when the design work started for the mission in general. The rover construction for the actual hardware that would be sent to Mars started a little bit later than that, around the 2018 timeframe, to get ready for a launch in 2020.
And I have another question for you. Shiva MSH24X on Instagram asks, what did you guys learn from Curiosity and how did it affect Perseverance's design?
We actually really appreciated the fact that we could analyze Curiosity's designs both in all phases of the mission, the cruise, the entry, descent, and landing, and the surface, and to make the changes to improve on it for the parts that we could. Now, we had to be very targeted about what those changes were, so we sought to improve in key targeted areas. And then we added to Curiosity design to allow Perseverance to enable its mission by adding the new sample capture system, adding better wheels in order to allow Perseverance to drive farther and faster, adding the whole terrain navigation system to allow Perseverance to land more accurately than Curiosity could.
And you can kind of see some of that in this Optimism rover behind you because it's a twin, correct?
This is a twin of Perseverance, correct.
Great. Now, Rachel, Jocelyn on Instagram asks, what is the most interesting discovery the rover has made so far?
Yeah, that's a great question. And so, like I said, we came to our landing site, Jezero Crater, to look at the ancient delta system that we have preserved there. Now, we've spent most of our time so far exploring the crater floor. And leading up to landing, we weren't really sure what we were going to see once we landed in the crater and explore the geology and the rocks that make up the crater floor. It was actually kind of interesting because our science team was sort of split 50-50 in groups that thought we would see sedimentary rocks on the crater floor, so things like lake deposits similar to what Curiosity has been seeing in Gale Crater, whereas the other half of the team kind of thought we might be seeing igneous rocks in the surface exposures on the crater floor. After a couple of months of exploration and a couple of samples that we've collected, we've actually confirmed that almost all of the rocks that we've been seeing in the crater floor are indeed igneous in origin, so that's been a surprise to us.
Thanks, Rachel. Now taking it back to entry, descent, and landing, Swati, Free Advice on Twitter asks, did you have any backup plans in case any failures happened, including the landing?
So when we design entry, descent, and landing, it's really hard to test that in Earth because you can't put it together all the way. So to make sure we have all our bases covered, we do try to build in as much protections as we can because the rover has to do it all on its own. There's no opportunity for us in mission control to be able to give the rover any instructions to change. So for example, one of the nice backup features that we had was that if we had any hiccups with the main computer that was controlling during entry, descent, and landing, we did actually have a mechanism that we had the backup computer on standby that if something happened, we could swap to the backup computer and continue entry, descent, and landing successfully.
Yeah, and speaking of all the cool parts, Rachel Nick on Instagram asks, what is the coolest piece of technology on the rover that helps scientists gather info?
Oh gosh, that's another tough one. It's hard to choose just one. I think, with all of the missions that we've been sending to Mars, it's really important to be able to interpret the geology of our landing site. And we do that mostly by taking pictures of our surroundings. So I would have to say, if I had to pick a piece of technology, it would probably be the cameras that we have on Perseverance. Perseverance has 23 cameras. Many of them are color cameras. Some of them can even zoom. And so we can really image all of our surroundings in really incredible detail with Perseverance.
Thanks, Rachel. Lots of questions coming in. Swati, Juan Camilo on Instagram asks, what programming languages are involved in the rover's daily functions?
Yeah, that's a good question, actually. So the software on board the rover is primarily in C, but we use many different languages here on the ground to do different functions like analyzing data or running test scripts. So we've used things like Python and MATLAB and see here on the ground in a variety of different functions to help the rover do its operations.
And 24/7 Canes on YouTube asks, what have we learned about the weather on Mars and how would it affect future missions? I don't know which one of you would like to take that.
I can take that. So we have a couple of instruments on Mars that are on Perseverance that are helping us characterize the daily environment. We have an instrument called META, which is sort of like our weather station on Mars. And so we're looking at things like the weather, the radiation, the dynamic environment that's changing every day on Mars. And we found that there's quite an active atmospheric cycle on Mars with Perseverance so far.
Great. And Scout on YouTube, first off, gives you a shout out. Thank you for all the amazing work on the mission. Now, what is on the horizon for 2 years in terms of scientific goals, experiments with the rover, and possibly helicopter?
Yeah, so we have a couple of main mission objectives that we hope to accomplish with Perseverance. The first is to characterize the geology of our landing site, which we've been hard at work doing in the last year, looking at the crater floor. Looking forward, we're going to be exploring the delta in the next year of our mission, and then beyond the delta, looking at sort of the margin of the crater and hopefully beyond the crater itself in future years with the mission. We also plan to look for signs of ancient life in the rocks that we're exploring in Jezero crater, and so we have a really sophisticated set of scientific instruments to tell us about the mineralogy and texture of the rocks in a really fine scale detail. And so we're constantly learning more about the geology around us, and we're going to be exploring a whole bunch of really exciting places over the next couple of years.
And we have a question from Richard on YouTube who wants to know, does Ingenuity need to be in the line of sight to communicate with the rover? Like, how far away could it be to stay in contact?
I can take a stab at that one. Yeah, so
we can also get back to them too.
I can speak a little bit to the helicopter. So our sidekick helicopter Ingenuity was meant mostly to be a technology demonstration for be able to demonstrate that we can achieve powered flight on another planet. And in sort of standard NASA fashion, we really exceeded our expectations with Ingenuity and transitioned more into an operations demonstration with the helicopter. And so Ingenuity has been really helpful in sort of scouting the places that we want to visit and places that we actually can't visit because of the terrain with Perseverance. And so we've been using Ingenuity so far in the last year beyond our technology demonstration to help us plan in operations.
And then Saeed91EK on Instagram asks, why doesn't the rover examine the samples that it collects?
Yeah, that's a good question, and it turns out that we actually do in a way. And so when we find a rock that we're interested in sampling, we drive up to it. But before we collect a rock core sample, we actually use one of our different coring bits called an abrasion bit. And what our abrasion bit allows us to do is drill the upper couple millimeters of the surface and reveal sort of a 5-centimeter abrasion patch that lets us use our scientific instruments that we can put in very close proximity to that fresh surface to tell us in really fine detail what minerals are there, elements are there, and what the texture looks like at a really fine scale. And so once we're done with the abrasion and the analysis of the abrasion patch, we can then choose our coring target. And we normally pick a coring target that's pretty close to the abrasion patch. And of course, once we collect our core sample, it gets sealed into one of these ultra clean sample tubes. This is a full-scale model of what the sample tubes look like. And once we collect the sample into the tube, of course, it gets sealed and stored for later retrieval to Earth, hopefully in the future. But once it's in the tube, we can't analyze it, like you mentioned in your question. And so by studying our abrasion patch with our science instruments, we use that data sort of as a proxy to help us understand what we could be expecting to find in our core samples.
And how many samples have you collected so far?
So far, we've collected 6 rock cores of the crater floor in our past year. We're hoping to collect about 2 more before we wrap up our activities on the crater floor.
Now, Twalo on YouTube asks, is the Mars rover behind us real, or is it a copy of it? It'll be nice to speak more of it. Swati, if you want to kind of touch on what parts were part of EDL, and then maybe entry, descent, and landing, I should say, and Rachel talk more about the science. Go ahead.
Sure. So Optimism is real. It's a fully functioning rover that we use here on Earth. So it does have a few modifications from the rover that is on Mars, primarily to allow it to work here on the Earth. So the wheels are a little bit different in terms of suspension to handle the Earth gravity. But in terms of the electronics on board, in terms of the cameras and the processing, we try to make it as similar to Perseverance as we can, so that when we are testing our sequences, our planning here on the ground, we can have a really good expectation of how it'll work once it's on Mars.
Yeah, and then from a science perspective, you can see mock-ups of all of the different instruments that we have on the rover on Mars for real. So we can see, looking at us here, is one of our cameras on the end of the robotic arm. We also have the remote sensing mast, which at the moment is pointed away from us, but has a couple of additional cameras on top of it that serve as sort of our eyes as we're exploring the terrain around us.
Great. And then Oleski on YouTube asks, what was the biggest challenge during the mission that you had to overcome?
Oh, that's an interesting question. There was a lot of challenges during development, but from my perspective as the guidance navigation operations lead, I would have to say rethinking how we had to do operations and our final assembly in the light of the pandemic was one of the big challenges. You know, we've never had to fly a mission like that, and it was constantly a tug of war between the personnel safety here on Earth and the safety of our hardware either in space or in the final assembly. So constantly having to make those trades as to how we were going to balance and how we would rethink what it meant to be working remotely with our spacecraft was a big challenge. And I'm really impressed with the team for pulling together and pulling through for an on-time launch in spite of the pandemic hitting just a few months before launch and making it all the way to Mars for a very successful landing. And the entire time we've spent since then working as the pandemic's been ongoing.
You made the whole thing look easy. Congratulations to the team on that. Rachel, what about for you?
Yeah, since we've been on the surface, we've encountered our fair share of curveballs from Mars too. I mentioned the first time that we sent our sampling plan up to the rover to collect a sample in one of our sample tubes. Once that plan executed on Mars, everything worked perfectly from our hardware perspective. But then when we started to analyze the data that came down, we actually saw that the tube was empty and didn't contain a rock sample as we were anticipating it would. And so we constantly have to adapt as Mars throws us curveballs and challenges, but everything from the rover's perspective has been working flawlessly.
Great. And for Swati, Tyler Williamson on YouTube asks, actually for both of you, what type of degree do you need to become a NASA engineer?
That's a great question. There are so many different ways to contribute to NASA. You know, we generally like to look for some degrees in science and technology, and it doesn't have to be just one particular area of science or one particular area of engineering. You know, find what makes you the most interested, where your passion is, and there's so many different ways to apply that to NASA programs, whether it's, you know, geology of Mars or chemistry as we think of planetary protection, or, you know, even biology as humans go into spaceflight, or in the traditional like structures and controls and mechanisms. You know, we need all of those different fields in order to support NASA missions, in addition to all the non-technical fields like the writing and the publicity and things like that.
It's a wide range of jobs. What about for you, Rachel?
Yeah, I couldn't agree more. I think one of my favorite things about being a part of the Perseverance team is that no two team members have the same path or the same level of experience or background. And so you really have to find what interests you and pursue that and work really hard.
And Erica on Twitter asks, what do you hope to accomplish with this mission overall?
Oh yeah, so I can touch on that first. So we talked a little bit about sort of the mission objectives that we hope to accomplish with Perseverance. At the top of the list, for many reasons and for the future missions that Swati talked about, is to collect samples. And so we brought over 40 sample tubes with us to Mars, and we hope to fill most of those with samples of Martian rock and soil to eventually bring back to analyze here on Earth.
Yeah, so when we have the chance to bring those samples back to Earth, we can actually unleash the whole arsenal of the scientific community here on Earth to look at those samples and to look at them in the hopes of finding signs of ancient life on Mars. And if we can find those signs of life on Mars, even ancient life, that would fundamentally change how we look at how life evolved here on Earth and whether there's life elsewhere in the galaxy.
And Alit on YouTube asks, I feel like this is rhetorical, how does it feel to be an awesome lady scientist and engineer?
Oh, it's fantastic. And just revisiting what I said earlier, it's just so humbling to be part of such an amazing team. Everybody is extremely supportive. We have a very diverse team, and it makes everything that we do even that more satisfying.
I totally second Rachel.
Perfectly said. MG Steve on YouTube asks, are you concerned about the samples being covered by dust on the surface before a mission recovery can pick them up?
That's a really good question. And so the samples will be securely stored in these sample tubes like we mentioned earlier. And we're still working out the details of exactly how we're going to be depositing these samples on the surface for eventual pickup and return to Earth. We know that Mars has a very active, dynamic atmosphere, and so we see dust storms and things like that that affect the rover and other missions across the planet. But we're not really too concerned about our ability to see the samples when we're ready to pick them up.
Lots of questions of the rover coming in. Jay Kendall on Instagram asks, how is maintenance conducted?
Well, that's a good one. From at least a science perspective, we have a whole bunch of science instruments on the rover, and we're constantly making sure that our instruments are working properly. We have calibration targets on the rover that we periodically check to make sure that the data that we're acquiring is very high quality. So we're kind of periodically, as we're going, checking in on our instruments and our rover to make sure everything is healthy.
From the engineering side, we also do ongoing maintenance. We make sure to trend all of the data that we're getting back from the rover to make sure it's performing as we expect. If we have to do any tuning of the rover to upgrade parameters to properly capture what the state of the rover is, we have those built into the plan to do periodic maintenance of the rovers as it evolves on Mars.
And Swara on YouTube wants to know, how was landing different from Perseverance compared to Curiosity or even the other rovers? Oh, we can hear hear moving up there.
So Curiosity,
there we go. Yeah, go ahead.
Optimism wants to hear our answer too, actually. Curiosity and Perseverance landings were actually very similar. Perseverance had a few upgrades compared to Curiosity that allowed it to land much more accurately than Curiosity did, very targeted upgrades. One in terms of how we deployed the parachute, and another in terms of how we picked our landing site to make sure we could find a safe spot in Jezero Crater. Curiosity and Perseverance compared to Spirit and Opportunity were a little bit different. Curiosity and Perseverance actually had a guided entry system with the sky crane to actually lower the rover onto the surface, whereas Spirit and Opportunity had a parachute, and then it would inflate these airbags around them, deploy them, they would kind of bounce, and then the airbags would deflate, and then the rovers would open up and it would drive off from those systems.
And this was the first time that we had this on video, correct?
Perseverance was the very first time that we could actually, we had so many cameras recording during landing that we could actually see things as it happened. It was the first time that we saw the parachute open, which was just an amazing feeling because that's one of our highest criticality things. If the parachute doesn't open, you don't get very far on Mars. It could actually record the rover being lowered from the descent stage, and that was just an incredible video. It looked like an alien planet, which maybe it sort of was, but to be able to see that gave us so much more data than just the ones and zeros, because now you could see everything was happening, all the nuances associated with that, associated with the parachute and the intricate dynamics associated with how the bridles work to lower the rover, which is just immense amount of data that I'm sure we'll spend so much time analyzing for the future missions.
Very incredible video. Now, Jonathan on YouTube wants to know, to what extent is Perseverance autonomous, and how much does someone actually drive it?
Yeah, that's a great question. And the way that we plan mission operations with Perseverance is that we send one to a multiple days worth of activities, or SOLs, up to the rover at a time. And so the rover needs to have some level of autonomy to be able to perform those activities. And then at the end of the day, we get those data down to plan the next day's activities. We have a really incredible autonomous driving capability with Perseverance that we're still evolving to this day. That's allowing us to break all sorts of records for distances driven on Mars in a single SOL. So it's been really exciting.
Do you by chance know how far it's gone in a single day?
Oh gosh, I think we broke a record over Super Bowl weekend, which was very appropriate.
I think we broke both the autonomous driving record and the actual wheels turning in a single SOL record.
Yeah, it's amazing.
Got our champ here. Now, Lou on Twitter wants to know, does Perseverance have a wake-up song like the other rovers?
We do have a wake-up song, and we play that as we're sort of reviewing the data that come down to start our operations day. And it's a different song every day, and it kind of gets us in the mood to plan our operations every day.
That's great. And Talo on YouTube wants to know, will someone send another rover to Mars to pick up the samples, or will Perseverance come back sometimes? Swathi, you might know that one?
Sure. So I guess part of that question is whether Perseverance will come back.
Yeah, they want to know if it's a separate mission or if it's Perseverance coming back.
You know, there's still a lot of things that we need to work out with the whole campaign of how we're going to get these samples back. There's multiple different pieces and how we work them together. And so right now the option space is still open in terms of how we're going to get the samples back to the lander with the rocket, who's going to go get the samples, whether it's Perseverance or another rover. All those pieces are still being worked out. We're still in the design phase of the campaign to start deciding those.
And then does Perseverance communicate with other rovers on Mars, and how does it communicate with Earth? This is Nikki on YouTube asking.
That's a great question. As awesome as it would be to sort of chat with the other vehicles that we have on Mars, they're all really far away from Perseverance. So we communicate with the rover using our fleet of to drive through. So that's why we really like using Ingenuity to sort of get a feel for what these terrains look like from the helicopter's view.
And Musical Wolves on YouTube wants to ask, how are the rovers' locations being tracked? And we have time for 2 more questions after that.
How are they being tracked? So our missions to Mars and our rovers on Mars land in very specific landing sites. And so, as I mentioned, we have satellites around Mars that sort of serve as our communications relay. We can also sometimes take images pointing down at our landing sites to sort of check in on the rovers to see what sort of progress we've been making. So it's always really exciting to be able to see pictures of the rover on Mars taken by a satellite.
And then Takek on YouTube asks, how long might Perseverance maintain enough power to conduct science?
So Perseverance was actually designed for 1.5 Mars years, which is roughly about 3 Earth years. That's how much it was designed for. We've had fairly good success rates for rovers on Mars, lasting 8 to 10 years past their initial design life. So fingers crossed that Perseverance has a nice long future ahead of her.
Great. And we always get questions like this. How did you both get into your career fields?
I can start with that one. So I actually grew up watching Star Trek, so I loved the whole concept of space and exploring space, but it wasn't until I was a junior in high school that I had a really great physics teacher, and that opened me up to what engineering was and what it meant to build things that could actually go and do that exploration. And that's how I made my way to JPL.
So exciting.
Rachel?
Yes, my movie of inspiration was actually Apollo 13. So when I was young, I was always really interested in NASA missions, especially the Mercury, Gemini, and Apollo missions that brought astronauts to the moon in the 1960s. So when I went to school, I ended up finding a really strong interest in geology. And so when I went to graduate school to get my PhD in geology, I had the opportunity to join the Curiosity rover team as a graduate student. And once I got sort of my first taste of what it was like to work in science operations, I was totally hooked. And so afterward, I came here to JPL, and now I work for Perseverance.
It's great to hear that you were both inspired by sci-fi programming. That's great. Now, that is all the time we have for questions today. Thank you so much for answering all of our questions. And thank you everyone at home for your questions. Now, to learn more about Perseverance, follow at NASA Persevere on our social media channels and visit mars.nasa.gov. Thanks for watching.